This is Joshua from MOTIVAO. Welcome to another episode of How's it going, guys? It's Joshua from MOTIVAO Online Instructors. Today we're going to find the minimum length of the crease using the ratio method. And the reason I call it the ratio method is because we're going to be using similar triangles. So let's go straight to the diagram. Now, zoom out a little bit. Okay. Now notice that I've added some new variables, and these variables are going to be the angles of each triangle. And the reason I put the Greek alphabet on them is because mathematically that's how we express usually angles. So I wanted to put for the angle GDE as alpha, GED as beta, EBF as C, BEF of phi, and so on, just like I have it in the right column. Now look at the left column. Notice that I have these equations. How these equations come out to be? Well, we know that all these triangles are right triangles. So that means that they have at least one 90 degrees angle. And since the angles inside a triangle have to add 180 degrees, we need that alpha plus beta, sorry, for example, has to be equal to 90 degrees, which I wrote here as pi over 2. Now the same thing for phi and c, and the same thing for nu and omega. Now notice this one here, beta plus phi. The reason this is pi over 2 is because this angle in the middle is 90 degrees, and by the same reasoning, these have to add 180 degrees, which implies that beta plus phi has to be 90. And the same reasoning here, C and these two angles are the same because these two triangles are exactly the same. So C plus 2 nu equals pi. And here, 2 omega plus alpha equals pi over 2, which is 90. Now, to be able to use the similar triangles, we need that all these angles have to be the same. And so here we want to prove that beta is equal to C and that alpha is equal to phi. Okay? Now, let's start. Let's start by manipulating these equations. So we have that alpha equals pi over 2 minus beta, and that beta equals pi over 2 minus alpha. The same thing for phi equals pi over 2 minus beta, and beta equals pi over 2 minus phi. Now, I want to use these two because they have this 2 value. So let's rewrite them. Now we have 2 nu equals pi minus c, and 2 omega equals pi over 2 minus alpha. Now, what can we do from here? Well, notice this one that I've isolated here, omega plus nu. Let's write this one in the right side here. Omega plus nu equals what? Well, equals pi over 2. Now let's multiply this one by 2 in both sides. So we have 2 omega plus 2 nu equals pi. Now 2 omega plus 2 nu equals pi. But 2 omega equals pi over 2 minus alpha, and 2 nu equals pi minus c. So let's add these two together and equal to pi. So we have that pi minus c plus pi over 2 minus alpha equals pi. But this information gives us, well, if we isolate c and alpha to the right side and bring pi to the left, we have that pi over 2 equals alpha plus c. Now this is very important because this is what I'm going to use to solve, to prove this. Now that we have this implies what? Well, two directions. That C equals pi over 2 minus alpha, and that alpha equals pi over 2 minus C. Okay? Now, let's use, well, we want to prove that beta equals C, or that alpha equals phi. So let's prove that beta equals C by substituting alpha. Alpha here is pi over 2 minus beta. So let's substitute right there. Straight from that fact, we have, well, we have it already over here. Pi over 2 minus alpha equals beta. So we can substitute here and say that C equals beta, which is what we wanted. And for alpha, well, pi over 2 minus C. Well, we know from this one that pi over 2 minus beta equals phi, but we already proved that C equals beta. So we can just straight substitute that into that equation. So we have alpha equals pi over 2 minus beta, which is what? Well, pi over 2 minus beta is phi. So we have that alpha equals phi, which was our second condition that we wanted to prove. Now that we have proven that all these angles are equal, that means by AAA theorem that this triangle is similar to this one. And why do we want that? Well, that means that their lengths are ratio to each other. So I'm going to use the 90 degrees length, which is y. So y is as what? Well, the 90 degrees of this one is x. Equal to what? Well, I'm going to use the 8.5. And the 8.5 is the angle of whom? Beta. But beta is equal to c. So beta is to 8.5 as c is to z. Okay? Now, this implies, let's move it a little bit to the right. This implies what? That y equals x over z times 8.5. Okay? Now let's square them, let's square both sides. We have y squared equals 72.25 x squared divided by c squared. Now notice that these two equations come from Pythagoras. So this one implies that c squared equals 17x minus 72.25, and this one will give me the minimum of c. Now substitute this equation into here and this one into this equation. So what do we have? If we substitute this one, we have that y squared equals 72.25 x squared divided by 17x minus 72.25. Now let's add them together. Let's substitute y squared into this equation. So c squared equals this term, 72.25 x squared, 17x minus 72.25 plus x squared. So that means that we'll have to find a common denominator, which is the term in the bottom. So let's do that. So c squared equals 72.25 x squared plus x squared times 17x minus 72.25. Everything divided by 17x minus 72.25. Now notice that this x squared with this negative 72.25 will cancel this one. So we're only going to have 17x cubed. So this is equal to what? Well, 17x cubed divided by 17x minus 72.25. Now this is c squared. Now, if we factorize at 8.5 in everything, what do we have? We have 8.5 times 2x cubed divided by 8.5, 2x minus 8.5. They cancel out, and we have left, this is equal to 2x cubed divided by 2x minus 8.5. But this is c squared. We want c only. So c of x is equal, again, as in the previous videos, the square root of 2x cubed divided by 2x minus 8.5. And this is our c, which we're gonna maximize. And if you want to keep learning about this exercise, go to my next video where I take the derivative and find the minimum. Thank you for watching.
Guys, if you were astonished on how clear this was for you, imagine what I can do in a one-to-one session where I can pinpoint your weaknesses and make them stronger, thus making you a smarter version of yourself. Go to MOTIVAO.com.
MOTIVAO like instructors. MOTIVAO. MOTIVAO.com. Come on, let's go. Great. Go in my eyeball. Hey, mouse, go in my eyeball. I can't get in.